All right, so section 2.4, we're going to take a look at graphing sine and cosine. Now, as we've gone through trig, we've studied 6 different functions: sine, cosine, tangent, cotangent, secant, and cosecant. As far as graphing, in this class, we only graph sine and cosine. Okay, those are the only 2 that we look at. And does anybody know what sine or cosine looks like when you draw it? Yeah?
Sine is like this.
Yeah. Okay, so the graph of sine looks like a wave. Okay. What's kind of unique about the wave is it keeps repeating forever. So even if you zoom out, you're still going to see the same picture repeating forever. And it's the same thing with cosine. If I put the graph of cosine up, it looks similar, but the graph of cosine has just moved to the left a little bit.
So they're pretty much the same.
Yep, so sine and cosine look very similar. Okay, the other 4 trig functions, like tangent, cotangent, all the other ones, they do not look like that. I'm going to show you tangent. We don't study it. There's a pattern to it. It's the same thing that keeps repeating over and over, but it's not a continuous wave. Right? It's these curves that you have to keep picking your pencil up as you draw.
That looks like a lot.
Yeah. So we're just going to focus on sine and cosine. When you have a graph that repeats itself like that over and over, that's called a periodic function. I think that's the first thing I mentioned. Yep. Those are called periodic functions. Okay. When you draw a line, or you draw a parabola, you draw any other kind of function that's not trig, it's not periodic. Okay, so why are they called periodic? Well, let me go like this. Let me put up just sine. Okay, so that's the graph of sine. Okay, what I want to look at as we trace it, I want to look at how high and low the graph goes. Okay, so it starts, let's say it starts right there. It starts at 0. And what does it look like the highest it ever goes is? 1. And then it goes back to 0. And how about the lowest? Negative 1. And back to 0. Okay. So these 5 values that I just said, 0, 1, 0, negative 1, 0. 1, 0, negative 1, 0. 1, 0, negative 1, 0. That pattern of 1, 0, negative 1, 0, it keeps repeating forever. So all those y values will keep repeating. That's what makes it periodic. And how far do you have to go before it repeats? Well, you have to go from that red line to that red line. That's the amount of, how can I say it? It's the distance you have to travel before it repeats.
Wait, Mr. Hager, wouldn't it be repeating right after that first arc, though? No. Oh.
So if you trace that section right there, and then you take it and put a copy of it right next to it, I don't have enough space, but if you could keep copying and pasting that section right there, that's what it would look like forever.
So a set of 2 of them is 1, not just 1?
So that's called one. We're going to give you a name for it in a minute, but that's called one section right there.
Okay.
What you're looking at, the proper name for that is one cycle. Okay. If I go like this, make a copy of it, and put them together like close enough, that's 2 cycles. Okay. So the amount of distance you have to travel from here to here is the distance you have to travel before the graph starts to repeat. If you travel beyond this mark, it's repeating. If you don't travel all the way to this mark, it hasn't started to repeat yet. That length that you have to travel from here to here, distance of that red line, that's called the cycle of the graph. Okay, it's called the cycle, or it's also called the period. Yeah, I'll mention both of those in a minute. So you'll hear me use those two words interchangeably. Now, one thing we can do is we can take that graph, and let me do something like this. I'm going to put a 3 inside, and I want you to watch how it changes. Yeah, what I've done is it's like I've squished it. Okay, I've compressed it. So now, if we take a look at that graph, let's put that one, let's put that there, and I'll just make it bigger. Oh, it didn't, oh well, it didn't grab it. Well, you can just look at it there. So now, the distance you have to travel to do one full cycle of the red graph, it's a lot shorter. Okay, it's been compressed. Right? I could also do something like this. 0.5x. How does the red one compare to the blue one now?
They're wider. The blue is wider.
Yeah, it's a lot wider, right? It got stretched out. So now the distance you have to travel to do one full cycle is longer. Okay? So what we're going to look at this week are 4 different transformations. That's one of them. That's stretching and compressing it horizontally. Okay, another thing that I could do is something like this. Let's do 3 sine x. This is not going to stretch or compress it horizontally. See if you can tell me what happened with this one. Yeah, this stretched it, but it stretched it up and down. Yep, so that's another kind of transformation, stretching and compressing it vertically. Okay, here's another one. Let's do sine of x plus 2. Okay, so there's the original. What did plus 2 do?
Put it up higher.
Yeah, that didn't stretch it at all. Right? All it did was take a copy of it and move it up 2. Right? And the last one I'm going to do is sine of x. Let's do plus 90. Okay, tell me what that one did. It moved it to the left. Yep. So that's the 4 transformations. Moving horizontally, moving vertically, stretching horizontally, and stretching vertically. Okay, so we're going to look at each one. We're going to do 1 today, 2 tomorrow, and we'll do 1 more on Wednesday. So what if you don't stretch or compress it at all? You just leave it alone. Just leave it the way it is. What is the distance from here to here?
4.
Well, it's, if you count the tick marks, it's 1, 2, 3. It is 4 tick marks, but each tick mark is not 1 in degrees. I just know because when I did the Zoom, my calculator told me that the x scale was going by 90s. Okay, so this is really
4
0,
times 90.
90, 180, 270, 360. So yeah,
How do we check what each tick mark is?
you can go to window on your calculator.
Okay.
You just press window. So to get from the beginning all the way to the end of one cycle, it is 360 degrees, or
A circle.
2 pi radians. Okay? And that's what we're going to be working with this week. We're going to be working with radians. So if I go on my window, let's put it in radians, and I set my window to go exactly from a minimum of 0 to a maximum of 2 pi, I will see exactly 1 cycle on the screen. That's 0. Let me just get rid of the other one. That's exactly 0 to 2 pi. If I set my window to go to 4 pi, how many cycles will I see now? Yeah, I'll see 2. Right? There's 1 and there's 2. Right? So every time you add another multiple of pi, it's like you're zooming out. And if I go 0 to 6 pi, that would be 3 cycles. Because the graph just repeats after the first cycle, when we sketch it, we are only going to sketch one cycle. Because the thought is if you wanted to sketch another cycle, you could just copy and paste it to do another one. Okay, so I pretty much already said that to you. If you go beyond the red line right here, you go beyond 2 pi, the graph is going to repeat. And what do we call that kind of function that repeats?
Periodic.
Periodic, yep. And this is the other term I was using with you guys earlier. I told you that the length that you have to travel before it repeats is called the period of the graph. It's also called the cycle of the graph. Bless you. Bless you. Bless you.
Thank you.
Bless you. Okay. Where we use the word period to describe the length of the cycle, more than this word itself. You do see cycle used, like if you're doing anything with electronics, you might talk about hertz. You talk about electricity. Most electricity in the United States, like at least alternating current, when you plug something in, like an outlet in this room, it runs at 60 hertz. It also runs at 120 volts, that's different. But it runs at 60 hertz. That's the frequency of the alternating current. Right? Some countries use 50 hertz. Right? So when you plug something in, if you look at like the transformer, like for your phone, or you read the writing on it, it'll tell you, a lot of them say 50/60, meaning you could use that in a US kind of outlet, or you could use it in another country that uses 50 hertz.
I once heard that in the UK that they use 240 volts.
Yeah. Well, yeah, there's a few things that are different. They use
240 volts but lower.
They use different frequency. They use 50 hertz. They use 240 volts, and the physical outlet is a different shape. Yeah. So that's why you got to be careful. Even if you get an adapter that would make it fit in the outlet, if you plug in something that's not designed to work on 50 hertz, yeah, it won't work. It's going to ruin it. Yep. Okay. So again, that's where you'd see cycles per second. So hertz is a measurement named after somebody with the last name Hertz, H-E-R, I think it's H-E-R-T-Z. And it stands for cycles per second. Right? But again, it's just not something we use a lot in this class. Right? So I'm usually going to refer to it as the period length, not the cycle length. All right, so when we are graphing a trig function, okay, how many cycles did I say you're going to have to sketch?
One.
Just one. But to graph that one cycle, you need 5 points. Okay, those 5 points will give you a pretty good approximation of what your graph looks like. Okay, so what are these 5? I call them like the 5 key coordinates, or the 5 important coordinates. You got the beginning and the end. You've got the middle, the high, and the low. That gives you a pretty good picture. You can do more than 5 points. You can't really do less. And we're always just going to stick with 5. Okay. Any question on that? All right, so what we want to do is figure out, I know I labeled these in degrees, we want to get used to labeling them in radians. So that would be 0. What's 360 degrees? That's 2 what?
Radians.
2 pi. That's 360. How about 180? 1 pi. How about 90? 1/2 of pi. So 0, pi over 2, pi. How about 270? 1.5, what's 1.5 as a fraction?
1 and a half.
And how about an improper fraction?
3 over 1.
That's 3.
1
over 4
3
pi?
pi over 2. What did I say, 1?
3 over 2. 3 divided by 2 is 1.5. Okay? So these are your labels in radians. 0, pi over 2, pi, 3 pi over 2. Question? No? So 0, pi over 2, pi, 3 pi over 2, 2 pi. So if we're going to do a transformation to this graph, right there, the first thing we have to know is where is it starting from? Okay? If we don't know these 5 points that I just marked, you're not going to be able to figure out where they're going to move to. It's kind of like if I said, well, I want you to, meet me 30 feet to the left. Well, to the left of what? You got to know where you're starting from to know where 30 feet to the left is. So I'm going to give you guys the original tables for sine and for cosine. Okay. Let's start with sine. These x values in the original table are coming from these 5 numbers right here. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay. What we need is the y values. So let's start with the first point. What's the y value of that point?
0.
0. Yeah. Starts right at the origin. Starts at 0. And then when you get to pi over 2, what's the y value there? 1. And then when you get to pi,
0.
we're back to 0. 3 pi over 2, that's the lowest it ever goes. And then 2 pi, you're back at the end of the first cycle, or you could also call that the start of the second cycle. It's the same thing. Okay, so where one cycle ends, that's where the next one begins. So now, any kind of transformation that we do, whether we shift it up and down, shift it left and right, stretch it up, compress it down, or stretch or compress it left and right, you're going to start with these 5 coordinates. Okay, and that's for sine. Okay, let's look at cosine. So cosine of x. Okay, I'm going to try to put it on the screen. We'll see if it works. Yep, that's it. Okay, so for cosine, we're going to start with the same x values. So this is 0. This first tick mark is 90 degrees, because that's what the calculator is going by, or pi over 2 radians. This one is 180. That's halfway, or pi. This one's 270, or 3 pi over 2. And what's the last one again?
2 pi.
2 pi, which is 360 degrees. Okay. So now, what's your y value for cosine when x is 0?
1.
So this one starts at 1. Okay. Doesn't start at 0 this time.
And then pi over 2 would be 0.
Pi over 2, we're down at 0. How about pi?
Negative 1.
So we're at negative 1,
And then 0.
and then back to 0,
And then 1.
and then we end where we started. Yep. You always end at the same one you started at. If you don't, then it wouldn't be connected.
You did something wrong.
Yep. So if these tables are not right, then every problem we do this week is wrong. Okay. So we really got to make sure we have those 2 tables correct. And you have to make sure you look at the right one. So if I'm giving you a problem that has sine in it, you want to use the table on the left. If I'm giving you a problem with cosine, you're going to do the table on the right. If you mix them up, then it's questions on either of those two tables?
Can we do like an hour time?
What's that?
Can we do like an hour time?
No, sorry. Yeah. Okay, so, yep. A little bigger.
I'm good.
All right, so now when we do a transformation, things are going to change in these tables. Like let's say we took a graph that looked like this. Let's take that. And let's say we shifted it up like that. Look at what happened. This coordinate went up to that coordinate. What would change in a coordinate if it goes up?
The Y.
The y would change. Yep. Now, if we took this graph and instead, let's say we took it and move it to the left. Now this coordinate is over here. What changes when you move something left and right? The x. Since we're only going to do one transformation at a time, one of these columns is going to change, depends on what transformation you do, and the other column is going to stay the same. Right? The only way they could both change at the same time is if I did two transformations at once, which we're not doing. Okay? Like if I went up and I went to the right. Now, to get from this coordinate to that one, the x and the y have to change. But that's a multi-transformation, and we're not doing multi-transformations.
At all?
No. Nope. We only do one transformation for every single problem. So one of these columns stays, the other one changes. Just depends on which one is which. Okay, and that's pretty much what I just said to you. Okay, so once you get your original table, you're going to look at what you need to do to it. You're going to modify either the x column or the y column. How you're going to modify it, well, that's what we're going to be learning throughout the week. Okay, so for every transformation, one of the columns will stay the same. The values in the other column will change. And that's pretty much all the background about graphing sine and cosine. Now I'm going to focus on how you do one specific transformation, which is shifting left and right. Okay, that's all we're going to do today. Today's left and right, and then tomorrow we'll be doing shifting up and down and stretching up and down. And then Wednesday is going to be stretching left and right. That'll be the last one. Okay, so when something moves left or right, what kind of transformation do we call that? Like what direction?
Horizontal.
Horizontal. Okay, so we usually call it a horizontal shift. Well, when you're doing a trig function, they call it a phase shift. Same, still the same thing. So when you see me refer to something as a phase shift, it just means horizontal shift. Okay, when you shift something, there is no stretch. You're literally just taking a copy of what you have and you're sliding it left or right. Okay, so we've done transformations on pretty much every function we've studied all year. When you shift left or right, do you think that involves adding or subtracting, or do you think that involves multiplying?
Adding and subtracting.
It is adding and subtracting. Any kind of shift, whether it's up and down or left and right, is always adding or subtracting. Okay. Shifting is always adding or subtracting. If you multiply, that is a stretch. Okay. We're not looking at a stretch today. That's tomorrow. Now, if you add, which way do you think the graph is going to move?
Depending on if it's negative.
To the right.
To the right.
So like if we had, like, let's say you had y equals x squared. Okay, so this is not a trig function, it's just a parabola. And then you did y equals x plus 3.
So you move to the right 3.
So you think that would move right 3. Let's try that. So again, that's not trig, but it's still going to be exactly the same idea when we do sine and cosine. So there's x squared. There's x plus 3 squared. And so there's the blue one. And there's the red one.
To the left.
So which way did plus 3 move it? It moved it left, yep. So plus
It's to the left.
is going to move your graph to the left.
Why did it only move 2 though?
It moved 3.
Oh.
One, let me do zoom 6 so you can see it better. I didn't have my scale set up right. I don't know if you can see it better now. 1, 2, 3.
I see.
So plus is going to move it to the left. Which way do you think minus would move it?
Right.
Yeah. So it's, now this one's going to go right over there. Yep. So that's one thing we have to remember about a horizontal shift. It's the opposite of what you would think. Okay, but that's what a horizontal shift will always look like. It's when you add or subtract, but it has to be inside the parentheses. Watch what happens if you put it outside. Instead of putting a minus 3 right there, put the minus 3 outside. What did it, when I put it on the outside, what did it do?
Brought it down.
Brought it down. That's a totally different transformation. Okay. So you want to make sure when you are adding or subtracting, if it's inside the parentheses, that is called a phase shift. So whenever we're looking at transformations, so there's 2 things we're going to look at. First thing we're going to look at is what kind of arithmetic is it? Is it the adding or subtracting, or is it multiplying? If it's adding or subtracting, it's a shift. If it's multiplying, it's going to be a stretch. Yep. So that's the first thing we look at. The second thing we look at is where are you doing it? Are you doing it inside the parentheses, or are you doing it outside? If it's inside, it's always horizontal. If it's outside, it's going to be,
Down. Or not.
which is vertical. Yep. So those are the 2 things you have to look at. What kind of arithmetic are you doing, and where are you doing it? All right, so here's our 2 rules kind of spelled out for a phase shift. If you have x minus a value, minus shifts it to the right. That's what we just looked at. If you have x plus a value, it's going to shift to the left. Yep. How much is it going to shift by? Well, it depends on what the value is. Technically, you can shift sine or cosine by any value that you want. I'll tell you the common amounts we usually shift by are 90 degrees, which is pi over 2, 45 degrees, which is pi over 4, and 180 degrees, which is pi. Could you shift it by 52 degrees if you wanted to? Yep. That's just not a common amount that we do. Okay, so that's going to be kind of the theme with horizontal shifts. They are backwards from what you would expect. You have to do the opposite. So if you see a plus, you need to go left. If you see a minus, you need to go right. And when we do the arithmetic for the transformation, that's also going to be the opposite. So out of the 4 transformations we learned, 2 of them you do the opposite, 2 of them you don't. This is one that you do. All right. All right, so now we have to go back to our original table and we have to modify those coordinates. If we shift things left and right, what part of the coordinate is not affected? The y. Because the y's are not affected, we can copy those down from the original table. Okay, and what's the original table? That's what I gave you at the beginning. So when you are doing a problem like this in the homework or on the test, you're going to have a table, and it's going to have 10 blanks in it. You need to fill in all 10 blanks. Half of them you can just copy down from the original table. In this case, you can copy the y's down. Now, which y's do you copy, sine or cosine? Well, you need to read the problem. In this problem, you're going to copy down the sine. In that problem, you're going to copy down cosine. So it just depends on which function I do. Okay, so if the y's are all going to stay the same, then that means the x's are, they're all going to change. Yep. So now we need to find the new x's. Now remember, if you have x plus and then something, plus is going to move it which way?
Left.
To the left. So what we want to do is when you are shifting, look at that symbol right there. You're going to look at that symbol, and then you're going to do the opposite of it. Why? Because if plus is going to move it to the left, the only way that I can take a point and move it to the left is if I make that point have a smaller x value. Right? I need to move it to the left. You need to subtract. That's the only way you can move something to the left. If you want to move something to the right, you need to add. Okay? This is not moving to the right. This is moving to the left. So you need to subtract. So the easy way to remember it is you always do the opposite for a phase shift. And what are you doing the opposite to? All the original x's. That's why if you have those original x's wrong, the 0, the pi over 2, if they're wrong and you do this, well, then all your answers are going to be wrong. Because you based your original tables off something that was wrong. Okay, so always do the opposite. Now, is that going to be true tomorrow we do the opposite? No. We're going to not do the opposite. But for today we do. Okay. Does everybody have the directions they need there to find the new x's? So let's try this one. Okay, so on the test, when you get a question, they're all going to be mixed together. All the different transformations that we learned. So the first thing we got to do is identify what this is. Okay? So ask yourself two things. What kind of arithmetic are we doing? The add, subtract, or are we doing multiplication?
Adding and subtracting.
Yeah, we're doing some kind of adding and subtracting. So that means it's a shift. Is it inside or outside the parentheses?
Inside.
Inside. Inside means horizontal. Outside means vertical. So it's inside, it's horizontal. It's subtraction, that means it's a shift. Okay. What I did is I copied down the original table just for reference this time. But what we want to do is our final table for sine of x minus pi over 2. Okay. What column is going to stay the same?
Y.
The y's. Since the y's are not changing, where do we get those y's from?
The right side.
Yeah, the original table right on the right-hand side. 0, 1, 0, negative 1, 0. Okay, on the test, this table is worth 10 points. You get 5 points from just putting those in. The other 5 points are going to be from the x's. So we're going to put our final answers in that box. Off to the side, I'm going to put the original x's. And I'm going to leave myself a little room because I need arithmetic. I need to do some arithmetic. Okay. First thing, am I going to add or am I going to subtract to all those x's?
Aren't they gonna share?
What's that?
Aren't they gonna share?
Share?
Like, the same for,
Well, they're all going to be the same. Yeah, we're either going to add to all of them or we're going to subtract to all of them.
subtract.
So it says, determine what has been added or subtracted. So let's look at this. We have subtracted pi over 2. And now it says do
So you have to add.
the opposite. So we're going to add. And how much are we going to add? We're going to add pi over 2. You always do the opposite of what you see right here. That's a minus pi over 2. Do a plus pi over 2. Okay, so that's what I need to do. Now in the box, I need my answers. Okay, let's start with 0 plus pi over 2.
Pi over 2.
So that one's usually pretty easy. The next one, we already have a common denominator.
2.
What's pi over 2 plus another pi over 2?
2 pi over 2.
That's 2 pi over 2, which would reduce to
Pi.
pi. Yep. Okay, next one, we don't have a common denominator. What could I put for a denominator for pi, because it doesn't have one?
1.
1. What's your common denominator between 1 and 2? 2. To get a common denominator of 2, what would you multiply 1 by?
2.
Multiply by 2. Multiply by 2. What's 2 pi over 2 plus 1 pi over 2?
3 pi over 2.
3 pi over 2. Next one already has a common denominator. I want to do it not reduced, and then we'll reduce it. What's 3 pi over 2 plus 1 pi over 2?
4 pi over 2.
4 pi over 2, which reduces to 2 pi. And the last one, again, I don't have a common denominator,
So put it over 1.
so put it over 1.
So it'd be 2 pi over 2.
So what's my
No,
common
4 pi
denominator?
over 2.
Yeah, so multiply top and bottom by 2. 4 pi over 2 plus 1 pi over 2.
5 pi over 2.
Right. Now, this is the reason why I didn't reduce them at first, because I wanted you to notice this. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. They always have a nice pattern. If we were going to keep going, it would be 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. Once you reduce it, you don't see that pattern, but you do always want to reduce it. Okay, so that is your table for a period change. There'll be 2 problems just like that on the test. 1 or 2. Any question on the first one? All right. Now, we made our table. What do you think the last thing we have to do is?
Graph it.
Actually answer the question, which is to graph it. Now, are these nice numbers for the x's?
No.
No. Then we don't want to number our axes 0, 1, 2, 3, 4, 5, 6. We don't want to number it that way. When you are labeling an axis, the rule is that you have to keep the spacing consistent. You can't do something like this. What did I do there? What's wrong with that? Yeah, I went from 1 to 2 to 5 to 6 to 7. So am I going by 3s or am I going by 1s? You can't do that. You just have to keep the spacing consistent. when we started with these values, right here, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Look back at the picture for those. Are those values all equally spaced? Yeah. And if we take 5 values like that, or however many values I just did, if they are all, I can't move them all together, but they were all equally spaced, and we shifted them all together, are they still equally spaced? Yeah. Right? If you take 5 things that are equally spaced and you move them all together, they stay equally spaced. So what that means, I would use those values in the table to label my axes. So this one will be 0. The next one will be pi over 2. The next one will be pi, 3 pi over 2, 2 pi, and 5 pi over 2. It's a little squished, I don't have a lot of space. But that's how I labeled each one of those tick marks. Now, what's the highest I need to go on the y-axis?
1.
1. So I'll put a 1 for that mark, and the lowest. Since I'm only going 1 to -1, technically I don't need to label these 2 marks right here. But I label them. And now, plot those points. So pi over 2 comma 0, right there. Next one is pi comma 1. Next one is 3 pi over 2, 0. We've got 2 pi, and you're at -1. And the last one, 5 pi over 2, you are back at 0. That is the new graph. If we wanted to compare that to the original would have been here, here, there, there, and there. Okay, you do not have to draw the original. I'm just showing you how the new one compares to it. It has been shifted to the right. Okay, on the homework tonight, I think the way it's set up is there's 2 graphs for each problem. The one on the left, you show me the original. The one on the right, you show me the new one. Okay. All right. Any question on that one? So that's called a phase shift. All right. Let's try this one. Okay. So when we look at that equation, to try to identify what it is, what is the first thing that you should look for?
Is there going parentheses?
Okay, are we doing something inside the parentheses or are we doing something outside? What is it here?
Pi inside the parentheses.
Inside. Okay, so we're definitely doing something inside. That means it's going to be horizontal. And what's the next thing we look for?
Addition or subtraction.
Right.
And we'll be doing subtraction because it's addition, we do the opposite.
So the next thing we look for, is there an addition or subtraction, or is it a multiplication? Multiplication would look like this. We have not done that yet. Okay, multiplication is when you put like a number in front of x. Since it's addition or subtraction, that means it's a shift. So it's a shift, and because it's inside, it is horizontal. Okay, because it's a horizontal shift, what column is going to stay the same?
Why?
Why? Can
From
somebody
the
tell me?
original.
What's that?
From the original.
From the original. Now I need my original values.
0, 1, 0, -1, 0.
Okay, those are original values, but just be careful what table we're looking at.
1,
0,
0,
-1, 0, 1.
Yes. So unfortunately, if you did put 0, 1, 0, -1, 0, all your y's would be wrong. You would have been doing sine instead of cosine. Okay, but we got it now. 1, 0, -1, 0, 1. Any question why it's these and not the other ones? Okay, so now off to the side. What are my original x's for cosine?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Okay. I didn't put those in the box because those are not the answers. They're what I'm going to use to help me get the answers. And Wyatt, am I going to add or subtract to all those x's?
You're gonna add them, subtract them then? Wait,
Subtract.
Which one?
subtract.
Why?
I'm not quite sure.
So when you see a plus pi,
You do the opposite.
remember, you do the opposite. So we got a plus pi, we're going to do minus pi. Yep. Okay. No decimals, so we're going to leave everything as a fraction with pi. Okay. What's 0 minus pi?
Negative pi.
Negative pi. Okay, the next one, we need a common denominator.
Over 1.
So put it over 1.
And times it by 2.
So times top and bottom by 2.
So it'd be negative pi? Or pi?
Wait, wouldn't you do the same to the other side though?
Nope, that already has a denominator of 2, so we don't
Oh,
need to
yeah,
change that
makes
one.
sense.
What's 1 pi over 2? Take away 2 pi
Oh,
over 2.
3 pi over 2. No.
If we were adding,
Pi
yes.
over 2. Pi.
1 take away 2.
Negative pi?
Negative pi. Negative 1 pi
Over 2.
over 2. Yep. So keep the denominator the same once you find it, and then just do 1 pi, take away 2 pi, and put that in the top. How about pi minus pi?
0.
0. Okay, what are we going to do with the fourth one?
Subtract 1. Put that in a fraction.
Put a
Make it a
one
fraction.
Over
But-
1.
over 1.
And then times it by 2.
Times it by 2.
And then you subtract 3 minus 2.
Yep.
Which is 1 pi over 2.
1 pi over 2. And 2 pi take away 1 pi?
2. No. One.
1 pi.
1 pi. So the pattern, if you wrote everything with a denominator of 2, this is negative 2 pi over 2, negative 1 pi over 2, technically 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. That's your pattern. Okay, so again, most important thing here is your table. Okay. On the test, I think the graph is only worth 2 points. The table is going to be worth 10. So the table is worth 5 times as much.
That's quite a bit.
Yep. There's a lot more work to the table than the graph. Okay. Any questions on how to get that table? Yep.
Why do we add pi by 2 on the top?
So when you have pi over 2 and you're subtracting pi over 1, if you want to subtract them, you need a common denominator. So if you double what's in the bottom, then you also have to double what's in the top. Yep. All right, now we have do our sketch. Were these original x values that I just circled equally spaced? Yes. We took and we shifted them all the same amount. Pi. Are they still equally spaced? Yeah. If we started with 5 things that were equally spaced and they all moved together, they're still equally spaced. Because of that, use those as your labels. You need 2 negative labels. So if this is 0, this would be negative pi, and this would be negative pi over 2. Pi over 2, and pi. If that was in degrees, I think you'd see it a lot easier that there's a pattern. That's negative 180, negative 90, 0, 90, 180. Next one would be 270, and then 360. Okay, what's the highest that we need to go?
1.
Lowest?
Negative 1.
So I don't need to label it. Okay, if I'm going to go by ones, I generally don't label it. So negative pi I'm at 1. Negative pi over 2, 0. 0, negative 1. Pi over 2, 0. And the last one is pi, and you're up at 1. Now, when you sketch that, remember, this is the graph that we're sketching a part of. You're basically sketching that section right there. So it should not look like this. It shouldn't be a V shape. Okay. Try to give it a little bit of a curve. Kind of like that. All right, so the dots look like a V, but when you draw it, it's just the middle section of the cycle. And then if I were to draw the next cycle, how would it look compared to this cycle?
The same.
Yeah, it would look exactly the same. You'd literally just take a copy of it, you put it right next to it, and there you go. That would be your next cycle. But we're just doing one. Okay, so any question on that one? Was this one a bigger or smaller shift than the last problem? Bigger. That was twice as big. This was a shift of pi. This one was a shift of half pi. How about this one? Is this one bigger or smaller than the last one? It's much smaller. It's a quarter of the amount of the last problem. So this is a very small shift. It's x minus pi over 4. Okay, so walk me through it. First thing I should ask myself when I look at that.
If it's a horizontal shift, like
Okay, so what are we looking for to identify that? Two things.
well, the addition or subtraction.
Okay, if we see addition or subtraction, we know it's a shift, and it's inside. So the two things. What are you doing? Where are you doing it?
We're adding
Yep.
pi over 4.
And we're going to add pi over 4. Okay, we know it's shifting horizontally, so which column stays the same?
Y.
Y. And now for sine. What are my y's?
0, 1, 0, negative 1, 0.
Okay, so we got five points just for getting those right. Okay. Next 5 points. Off to the side, put your original x's. And now, what are we going to do to all those?
Add pi over 4.
We're going to add pi over 4. Now, this is one where we're going to need common denominators for every one of them. Hopefully, after we do the first 2 or 3, you start to see a pattern. Once we see the pattern, we can just fill in the pattern. Okay. What's 0 plus pi over 4?
Pi over 4.
Pi over 4. Okay, the next one, pi over 2 plus pi over 4. What's your common denominator between 2 and 4?
4.
So you're going to multiply the bottom by 2
2 is 3.
And
4 over 4.
2.
and the top by 2.
3 pi over 4.
It's 3 pi over 4. Let's do one more and then see if we get the pattern.
It's going to be the same.
Okay, what's going to be my common denominator here?
4.
4.
So times it by 4.
Times the bottom by 4, top by 4.
So it'd be 5 pi over 4.
It's skipping by 2.
Then it would be 7 pi over 4 and 9 pi over 4.
Yep, perfect. So yeah, it's odd numbers. And it's skipping, right? It's skipping. That's important because when we graph it, you're going to notice something is skipping on the axis as well when we label the tick marks. Okay, so it's 1 pi over 4, 3 pi over 4, 5 pi, 7 pi, 9 pi. If you kept going, the next one would be 11 pi over 4, and then 13 pi over 4. Yep. Okay, so there's your table. Okay, any question on that?
No.
Okay, so now, let's think about how we're going to label the axes. If you get stuck labeling the axes, then forget about the pi over 4 for now. Just focus on 1, 3, 5, 7, 9. Let's pretend like we were going to put all these numbers on a number line. Where would 1 go? I marked 0.
Right next to it.
Would go right next to it. Where would 3 go?
Right next to the 1. Or would you skip it?
Well, that's the question. Do we put 3 right next to it, or do we have to skip?
You would skip.
You have to skip, because from here to here is 1 unit. If you put that as a 3, now you're saying from here to here is 2 units. You can't do that. So 3 has to go here. Where would 5 go?
You skip it again.
We have to skip because this is 4. We're not labeling 4, we're labeling 5.
So then you have to skip it again for
Yep.
7, and then skip it again for
And we're not labeling 8, we're labeling 9. So if you ever forget how to do it, just think of it with the numbers in front of pi. And now, all I'm going to do is put a pi over 4. I'm going to do it nicer down below. But that's basically what I'm going to do. There's your labels. That's how you do it. Okay, so let's do that on a nicer graph. So we've got 0. That's 1 pi over 4. We're skipping 2 pi over 4 and going to 3. We're skipping 4 pi over 4 and going to 5. Skip 6, go to 7. And I need more space. Okay, if you ever don't have enough space, just take your graph, make it a little bigger. We're going to skip 8. And we're going to go to 9. What is the highest and lowest for the y
1 and
values?
-1.
Yep, 1 and -1. So I do not need to label my y's. Okay, so pi over 4. We're at 0. 3 pi over 4, you're at 1. That's a 3. 1. 5 pi over 4, you're going to go back to 0. 7 pi over 4, maybe about right there. And 9 pi over 4, back to 0. My spacing got a little off with my tick marks, but that's pretty good. Okay, and that's the graph of sine shifted to the right, pi over 4 radians. The original would have been right there. So not much of a shift. There's the original. There's the new one. Okay. Any question on that? Okay. So the homework is going to be a worksheet. Okay, that is on Schoology, and there's 5 questions. For each question, you need to show the original graph and then the final graph. For the final, make sure you show the table. Okay, if you don't have the tables, then you're going to get half credit for all the problems. So five tables you need to show me for the final graph. Yes.
You have any printouts?
Yep, I can print that.